Okay, let's kick things off with something, well, pretty wild, actually.
Oh,
You know how companies try to keep new tech under wraps?
yeah, usually pretty tightly.
Well, someone, somewhere in China, managed to buy a Nintendo Switch 2 motherboard online.
Wait, seriously, an actual Switch 2 board before release?
Apparently so. Bought it on Xianyu, like a Chinese eBay, for about $150.
That's incredible. Did it work? Could they play games?
Ah, well, no. That's the catch. The board couldn't be powered on.
Okay, so no early gameplay scoop then. Shame.
Exactly. But the really interesting part, the gold mine for us, is the chip on the board. The NVIDIA one.
Right, the cell key, the system on a chip, that's the heart of the console.
Precisely. So even though the board was dead, that chip holds the clues. Our mission today for this deep dive is to unpack what that NVIDIA chip tells us about the Switch 2.
So we're talking CPU cores, GPU specs, maybe even the manufacturing process.
You got it. We want to get a real handle on its potential power.
And we're basing this on the analysis from, who was it again?
The folks at the YouTube channel Geeker1, they got hold of this board, or at least the info and pictures, and did a serious hardware breakdown.
Ah, Geeker One, yeah, they do some impressive deep dives. So they did the heavy lifting, the reverse engineering.
They did. And we're here to sift through their findings, pull out the key insights for you, and basically give you the shortcut to understanding what this Switch 2 might actually be capable of.
Sounds as a plan. So Geeker One looks at this board. What's the first thing they notice?
Size. It's bigger. Noticeably bigger than the board in the original Switch, and even the OLED model.
Okay, that fits with the rumors of the console itself being a bit larger overall. Makes sense.
Yeah. And another thing, a design tweak, the game cartridge slot. It's right on the main board now.
Oh, interesting. Integrated onto the PCB itself. Different from the original where it was kind of separate, wasn't it?
Exactly. Might not be earth-shattering, but it's a change.
Okay. What about the components on the board? What did they identify?
Some key players. Storage is from Hynix, 256 gigs of TLC UFS 3.1.
Nice. UFS 3.1 is pretty quick. A good step up.
Definitely. The MediaTek handling Wi-Fi and Bluetooth, Realtek for audio, standard stuff. But importantly, there's a two-phase PMIC power management chip.
Right. Controlling power delivery. How much can it handle?
It's rated to supply up to 34.4 watts to the main chip, the SoSCI.
34 watts. That's quite a bit of headroom. Potentially. Doesn't mean the chip will use all that constantly, especially handheld.
Good point. Efficiency is key.
Yeah.
What about memory, the RAM?
They found two 6GB Hynix chips, LPDDR5X.
So 12 GB total RAM.
Yep, 12 GB total running on a 128-bit wide bus, rated for 8,533 megatransfers per second.
That sounds fast. LPDDR5X, 128-bit, pretty modern spec.
It is. But,
Yeah.
you know, Nintendo, they often prioritize battery life over pushing speeds to the absolute max, so it's quite possible they'll run that memory a bit slower than its top rating.
Right, makes sense. Okay, let's get to the main event, the NVIDIA SoC itself.
The star of the show, what did they find out about it?
Well, first off, the physical size, it's big, like surprisingly big, 207 square millimeters.
207. Wow. How does that compare?
It's almost double the size of the Tegra X1 in the original Switch.
Double. Okay, that's significant.
And Geeker1 put it next to some other well-known chips. It's bigger than the GA107 in an RTX 3050 Ti laptop.
Bigger than a dedicated GPU chip.
Yep, bigger than AMD's Ryzen 7 840H, bigger than Apple's M2, even bigger than Qualcomm's high-end X Elite.
Whoa, that's unexpected. A Switch chip bigger than all of those.
It's quite the statement size-wise.
But we need to be careful, right? Bigger die size doesn't automatically mean more power. The manufacturing process, the density of transistors, that matters just as much, if not more.
Absolutely critical point. A bigger chip on an older process might not outperform a smaller one on a newer process.
Exactly. So what specifics do we have on this chip? Any markings, part numbers?
Yeah, the part number is GMLS30 revision A1, made by Samsung, packaged in Taiwan.
Samsung Foundry. Okay. Any dates?
Yep, packaging date was week 21 of 2024. And the PCB itself, the board, had a stamp from week 36, 2024. Gives us a rough production window this year.
Interesting. And did they manage to confirm the actual NVIDIA codename for the chip?
They did.
Yeah.
Through decaping, carefully removing the top layers.
Peeling the onion.
Ha, yeah. They exposed the silicon and confirmed the internal name.
T239.
T239. That's the name that's been floating around in rumors for ages, since the COVID days even.
It's always satisfying when those rumors pan out. And this T239 design, it seems it's not exactly brand new.
Oh, how so?
The tape-out date, basically when the final design was sent for manufacturing, was apparently back in 2021.
2021. Wow, so the design is a few years old already.
Seems so. Geekerwan compared it to the GA107 chip, like in the RTX 2050. That taped out in 2020 and launched in 2021.
So a longer gap between tape out and, well, eventual launch for the T239.
Yeah, it kind of adds fuel to those rumors that the Switch 2 might have been planned for earlier but got delayed for some reason.
Makes sense. Development timelines can be complex. Did they comment on the layout on the chip? How the different parts looked? They did. They noted it looked maybe a bit different, less sort of orderly than other NVIDIA Tegra chips like Orin.
Okay.
But they could still clearly identify the main functional blocks. The CPU cluster, the GPU cores, memory controllers, all that.
Right. So let's break those down. The CPU first. What are we looking at?
It's an octa-core setup, 8 cores, specifically ARM A78C cores.
A78C cores. Okay, that's a pretty modern ARM core design. Decent. Any cache details?
Yep. A shared 4MB L3 cache for all cores, and then each core gets its own 256 KB of L2 cache.
4MB L3, 256K L2 per core. Sounds like a solid CPU configuration, on paper at least.
It does. And here's a really interesting clue about the manufacturing process.
Oh yeah, what's that?
Geeker1 measured the physical size of a single A78C core on this T239 chip. And it's basically the exact same size as an A78AE core found on NVIDIA's Orin chip.
Orin. Now that chip we know is made using Samsung's 8nm process.
Yeah. Exactly. So if the core sizes match, it strongly suggests the T239 is also using a very, very similar process node. Probably Samsung 8mm or something marketed as that.
That makes sense. Did they compare it to other A78 implementations?
Yeah, they looked at core sizes on different nodes, and it made it seem very unlikely that T239 is on a more advanced, like 5nm process. The size just fits better with 8mm.
Okay, so CPU is likely octa-core A78C on Samsung 8nm class process.
Got it. Let's switch gears to the GPU. What's the architecture?
Confirmed as Ampere. That's the architecture from NVIDIA's RTX 30 series cards.
Ampere, okay. So RTX 30 tech, how many cores?
It has 6 TPCs, texture processing clusters, and inside each TPC there are 2 SMs, streaming multiprocessors.
Right, and the SMs contain the actual CUD cores.
Exactly. Each SM has 128 CUDA cores, so you do the math. 6 TPCs times 2 SMs per TPC times 128 cores per SM.
That's 1536 ZUDA cores.
Bingo, 1536 CUT cores. So those specs that were rumored seem to be spot on.
5036 Ampere cores. Okay, that gives us a baseline. But Geeker1 mentioned something unusual about the layout, didn't they? They did. It's kind of weird. The GPU cores aren't all clustered together neatly. 2 of the TPCs are physically separated on the die from the other 4.
Separated? That is odd for Ampere usually. Ampere layouts tend to be more uniform.
Right. And Geeker1 pointed out the separated layout actually looks much more like NVIDIA's newer architecture, Ada Lovelace, the RTX 40 series.
Huh. So even though NVIDIA calls Orin's GPU and likely T239's Ampere, the physical arrangement hints at Ada design principles.
Kind of looks that way. Like they borrowed some layout ideas from their newer designs, even if the core architecture is officially Ampere. It's intriguing.
Very. What about the size of the individual SMs? Did they compare those?
Yeah, they did. Assuming the same process node, each SM on this T239 chip is apparently smaller than an SM on the Orin chip. Okay. But larger than an SM on the big GA102 chip, the one in the RTX 3090.
Smaller than Orin, bigger than GA102. It's a bit of a mix and match. Makes sense if it's a custom design for Nintendo.
Exactly. Now, to really try and nail down that manufacturing process, Geeker1 went deep. They used techniques called FibSem and FibStem.
Whoa, okay. Focused ion beam scanning electron microscopy. Yeah, that's serious stuff. Looking right down at the transistor level.
Pretty much. They compared the T239 structure directly to the GA107, which NVIDIA calls their 8N Samsung node.
And similarities, differences.
Both. They found similarities, definitely, but also key differences, especially in something called the gate pitch. Gate pitch.
Ah.
The spacing between transistor gates, right? What did they find?
Well, the GA107 chip showed gate pitches of both 64 nanometers and 68 nanometers. That fits with Samsung's official specs for their 8nm node.
Okay, and the T239?
The T239 mostly measured at 68 nanometers, which interestingly lines up more closely with Samsung's 10nm specs.
Wait, 10mm? But other things look like 8mm.
Exactly. Some characteristics matched 8nm, but that primary gate pitch measurement pointed towards 10nm.
So what's the conclusion? Is it 10nm or 8nm?
Geeker1's conclusion is that NVIDIA's 8N node probably isn't a standard off-the-shelf Samsung process. It's likely a custom node.
This Tau.
Basically built on Samsung's 10-nanometer foundation, but incorporating some tweaks, some improvements, maybe some libraries or features borrowed from their 8-nanometer process.
Ah, okay. So it's like a hybrid, a 10-nanometer plus or an 8-nanometer light sort of thing.
Pretty much. A blend of 10-nanometer and 8-nanometer tech. NVIDIA will almost certainly just market it as 8N, but technically it seems to be this customized node. Think of it as 10-nanometer foundations with some 8-nanometer performance bricks added in.
Gotcha. So maybe optimized for cost or power or specific features Nintendo wanted. Okay, process node puzzle kind of solved, maybe. Now, the million-dollar question. Performance. How is this thing likely to run games?
Right. This is where GeekerOne had to get creative, obviously, since they couldn't run the actual chip. They tried to simulate the Switch 2's GPU performance.
How'd they do that?
They took a low-end laptop GPU, an RTX 2050. It's also Ampere-based, like the T239, but it actually has more CUD cores, 2048 versus 1536, and a narrower 64-bit memory bus compared to T239's 128-bit.
Okay, so not a perfect match, but the same family. What do they do to it?
They had to seriously underclock it way down. They targeted rumored Switch 2 clock speeds, around 755 MHz for a simulated dock mode, and a really low 421 MHz for handheld.
421 millihertz. That's very low for a modern GPU.
It is. They also had to simulate the lower memory speed and, crucially, limit the power consumption, the TGP. Especially for handheld, they brought it down to like 17-19 watts.
That sounds tricky. Getting a GPU to run that slow and power constrained isn't easy.
Apparently not. They mentioned getting some help from NVIDIA contacts just to bypass the usual software limits, preventing such extreme underclocking. Serious dedication.
Wow. Okay, so after all that effort, what did the benchmarks show? They used 3D Mark Steel Nomad Lite, right?
Yes. For the simulated docked mode, the performance landed roughly in the same ballpark as an older desktop card, the GeForce GTX 1050 Ti.
GTX 1050 Ti. Okay, I know that card. Decent 1080p card from a while back.
Exactly. But remember, the Switch 2 will have DLSS and maybe even some ray tracing capabilities, which the 1050 Ti definitely doesn't have. So that's potential uplift.
Good point. What about handheld mode?
Handheld performance was simulated to be around a GTX 750 Ti level.
750 Ti. Okay, that's older still. How does that compare to other handhelds?
It puts it roughly in the same league as the Steam Deck, maybe slightly faster overall graphically than the original PlayStation 4.
Steam Deck PS4 ballpark in handheld.
Interesting. And docked is 1050 Ti level. How does that stack up against, say, modern phones or other consoles?
Compared to mobiles, the dock's T239 simulation was faster than the iPhone 15 Pro's chip. Faster even than the original Apple M1.
Faster than M1. Impressive for integrated graphics in a console.
It is.
Yeah.
But it was still slower than the GPU in the Snapdragon 8 Gen 3 for Galaxy phones, and slower than AMD's integrated Radeon 780M graphics you find in some powerful handheld PCs or laptops.
Okay, so good, but not top-tier mobile integrated performance, and against consoles. Yeah, that's where the perspective shifts. The Xbox Series S, the PS5, even a last-gen RTX 3060, they're estimated to be roughly 4 times more powerful than this simulated Switch 2 docked performance.
4 times. Okay, so definitely not aiming for PS5 level raw power. That was never really expected, I guess.
No, Nintendo usually plays a different game, but the key comparison for many people will be against the original Switch. How big is the jump?
Right. What's the generational leap?
It's significant. GeekerOne estimates about a 7x increase in GPU power docked and maybe 7.5x increase handheld compared to the old Tegra X1.
7 times. That's a massive improvement generation on generation.
Huge leap. Now, NVIDIA has sometimes thrown around a 10x figure in talks.
Yeah, I remember hearing that.
GeekerOne thinks that 10x figure likely includes the performance boost you get from using DLSS. The raw hardware uplift seems closer to 7.5x.
Ah, okay. DLSS. NVIDIA's AI upscaling tech. That's going to be absolutely crucial for the Switch 2, isn't it?
Absolutely. It's the magic ingredient that could let it punch above its weight, making lower resolution rendering look sharp on a 1080p or even 720p screen without the full performance cost.
It could be the difference between playable and unplayable for demanding games.
Precisely. And to show that, GeekerOne actually simulated some specific game scenarios. Cyberpunk 2077, for instance.
Ooh, Cyberpunk. The benchmark torture test. How did the simulated Switch 2 handle that beast?
Okay, so docked mode, aiming for decent looks. They use DLSS set to quality mode. The game rendered internally at 720p, then DLSS upscaled it to 1080p output. graphic settings on low,
And frame rate.
around 30 frames per second. Playable, looked okay according to them.
30pp is low at 1080p DLSS quality.
Yeah.
Not bad for Cyberpunk on this hardware. What about performance?
For a performance target docked, they use DLSS performance mode, which renders internally at an even lower 540p before upscaling to 1080p. That hit around 40ps.
Okay, smoother, but probably looking softer.
Yeah.
Handheld.
For handheld, they tried matching the docked quality visuals, aiming for 30 FAPs. For a handheld performance mode, targeting 40 Fs, they had to use DLSS performance again, but this time rendering internally at just 360p before upscaling to the handheld screen's resolution.
360p internal. Wow. That must look blurry.
They said it was definitely blurry, yeah. But potentially still playable on the smaller screen. It really shows how much heavy lifting DLS is expected to do, especially handheld.
Blurry, but playable. The classic handheld compromise. Okay, what other games did they test? Black Myth, Wukong. That looks stunning.
Yeah, Wukong. Docked, 1080p low settings, DLSS set to balanced mode, rendering around 626p internally. They got roughly 30 Ps in some areas. Playable.
DLSS balanced, okay.
Yeah.
Could they push higher frames?
If they used DLSS Ultra Performance, the frame rate went up, but the image quality apparently took a big hit. Looked bad.
Right. And handheld Wukong.
Handheld, even at 720p low with DLSS Ultra Performance, it was struggling to stay at 30 pp's. Their take was a Switch 2 version would need serious optimization.
Oof. Sounds like that would be tough. What about Monster Hunter? Wilds. That's a big upcoming title.
Yeah, this one was surprising. Even simulating docked mode, 720p low settings, DLSS Ultra Performance, it still couldn't hit 30 fps reliably.
Not even 30p's at 720p DLSS Ultra Performance. Ouch.
And they said the visuals report that setting too. They didn't even bother simulating handheld mode for Monster Hunter, suggesting it just wouldn't be viable based on the results.
Double ouch. Okay, that paints a picture of the upper limits. Were there any more positive simulations?
Yes, definitely. Kingdom Come, Deliverance 2. Docked, 1080p, medium settings, DLSS performance mode, they saw a more comfortable 30-40 fps.
Okay, that's better. Handheld.
Handheld, 720p, medium, DLSS performance, could also hit around 30 fps, so more manageable.
Good to hear. What about online multiplayer? Like, could it handle Call of Duty?
They looked at the potential for games like COD, Black Ops 6, or Warzone 2.0. Docked, 1080p low settings, DLSS Ultra Performance, they estimated potential for over 50ps.
Over 50 fps. That's pretty good for competitive play. Handheld.
Handheld, 720p low, DLSS Ultra Performance, potentially over 40ps. So it seems like for certain types of games, especially maybe less graphically complex or well-optimized titles, it could offer a really solid experience.
Right, so the takeaway seems to be super demanding AAA games will need big visual cuts and rely heavily on DLSS, but less intensive or better optimized games could run quite well.
That sums it up pretty well for the GPU side, based on these simulations.
Okay, let's shift to the CPU then. We've got those 8 A78C cores. Sounds good, but the rumored clock speeds seem kind of low. Up to 1.1 gigahertz, maybe even less when docked.
Yeah, that 1.1 gigahertz max clock speed is a key factor. Low clocks save power but limit raw performance. Kikerwan tried to estimate this too.
How did they find another chip to simulate?
They used an NVIDIA or an NX developer board. It has similar A78AE cores. They locked its speed down to 1.1 gigahertz and also tested 1.2 gigahertz to mimic the potential Switch 2 CPU range.
And the results? Using something like Geekbench.
Yep, Geekbench 6. And honestly, their word was underwhelming compared to the GPU's potential.
Underwhelming how? How did it compare to other devices?
In multi-core tests, the simulated Switch 2 CPU scored only about 66%, two-thirds of the Steam Deck's CPU performance.
Only 2/3 of the Steam Deck. Ouch.
Yeah.
It uses older Zen 2 cores, right?
Yep. They also said it was similar in score to like a 10-year-old Intel Haswell i7 laptop chip.
A decade-old laptop CPU.
Okay. And in the modal space, it landed somewhere between a Snapdragon 855 and an Apple A12. So definitely not cutting-edge CPU power by today's standards.
That doesn't sound amazing on its own. But what about compared to the original Switch or TS4?
Well, it's a big upgrade. It's estimated to be roughly 6 times more powerful than the CPU in the original Switch, and also about 6 times faster than the old Jaguar cores in the PS4.
6 times. Okay, that's a massive generational jump for Nintendo. Even if it's not matching current high-end CPUs, it's way beyond where they were.
Exactly. Context is important. It's a huge leap from Tegra X1 or PS4, Xbox One CPUs.
But those benchmark comparisons sound a bit worrying. Did Geeker One look at how this kind of CPU might perform in actual games? Benchmark benchmarks aren't everything.
They did, and this is where it gets interesting. They simulated the CPU load on a PC. They took an 8-core Intel i7 10700KF, turned off hyperthreading, and clocked it down to 1.4 gigahertz to approximate the T239's potential.
Okay, simulating the CPU bottleneck. What happened in games?
Surprisingly, even in PC versions of Cyberpunk 2077 and Black Myth, Wukong games not optimized for this kind of low-power CPU, the frame rates held up relatively well, like 30-40 FPS in Cyberpunk, 40-50 in Wukong, mainly limited by the simulated GPU, not the CPU.
Really? So the CPU wasn't the main bottleneck, even when significantly underclocked.
It suggests that for the T239 package, the Ampere GPU might hit its limits before that octa-core A78C CPU does, at least in many gaming scenarios.
That's actually quite reassuring.
Yeah, and they pointed out that with console-specific optimization, developers could potentially get much more out of it, maybe very high frame rates like 120 FUTs in something like Doom Eternal, if the GPU can keep up and the game is optimized for those cores.
Right, optimization is key on consoles. Do they do mobile simulations too?
Briefly, they used a downclocked Dimensity 8400 mobile chip running at 1 gigahertz. It showed that even modern mobile titles like Genshin Impact or Wuthering Waves might hit similar CPU limitations on that simulated hardware.
So it's a capable mobile class CPU, a huge upgrade for Nintendo,
Right.
but optimization will be vital.
Precisely. And that brings us to the console advantage.
The secret sauce of console development.
Kinda, yeah. Developers targeting the Switch 2 will have a fixed hardware target. One CPU, one GPU, specific memory. They can optimize drivers, game engines, everything specifically for that hardware in ways you just can't do on PC with its infinite variations.
So the performance we see in these PC or mobile simulations might be the floor, not the ceiling.
Potentially, yes. Especially for CPU performance. GPU optimization often means visual trade-offs, lowering settings, resolution, etc. But CPU optimization on consoles can be about reducing software overhead, making code more efficient, getting more out of the silicon without necessarily making the game look worse.
Like squeezing more performance out through clever programming.
Exactly. Think about the original PS4 running Cyberpunk at 30 FPS. Its Jaguar CPU is way weaker than this simulated Switch 2 CPU. That shows what console-specific optimization can achieve, even on limited hardware.
That's a great point. The raw specs don't always tell the full story for console. Okay, let's try and wrap this up then. We've gone through this leaked motherboard, the T239 chip analysis, the performance simulations. Quite a journey.
It has been a fascinating glimpse behind the curtain.
So for everyone listening, what are the main takeaways? What should they remember from this deep dive?
Okay, key points. 1, the hardware is real, based on this leak. We're looking at a custom NVIDIA chip, the T239, likely using a hybrid Samsung 10mm process.
Right. Big chip, custom process.
2, the GPU is Ampere-based, RTX 30 series tech, with 5036 cores. It offers a huge performance leap over the original Switch, maybe 7.5x raw power. Performance seems to land around a GTX 1050 Ti level when docked, and Steam Deck PS4 level handheld.
But DLSS is the key enabler.
Absolutely. DLSS will be critical for making demanding games look good and run smoothly, doing a lot of the heavy lifting.
3, the CPU is an octa-core ARM A788C setup. It's a massive upgrade from the original Switch, maybe 6x faster. But compared to current high-end CPUs or even the Steam Deck, its raw performance seems modest, likely due to low clock speeds for power efficiency.
Yeah, solid but not spectacular on its own, which leads to the final point.
Optimization.
Optimization and the console advantage. The CPU might look underwhelming in benchmarks, but console-specific development could unlock significantly more performance than simulations suggest. Don't underestimate what Nintendo's developers and third parties targeting the hardware directly can achieve.
Great summary. Okay, so here's a final thought for you to chew on. We've got these specs. A pretty capable GPU, boosted by DLSS, paired with a decent, but maybe not world-beating, CPU. We know Nintendo often focuses on unique gameplay rather than just raw power.
Right, they innovate in different ways.
So given this specific hardware profile, this kind of hybrid performance where the GPU might be relatively stronger than the CPU and DLSS plays a big role, what kinds of unique gaming experiences could the Switch 2 excel at? What new types of games or features might Nintendo lean into that play to these specific strengths, beyond just trying to run prettier versions of existing games?
That's a really good question. What does this particular balance enable?
Something to think about. What unique Nintendo magic might they conjure with this specific set of tools? Ponder that, and we'll catch you on the next deep dive.